Graphing a hyperbola in standard form is not bad. This is in standard form. Something squared over something minus something squared over something equals 1. Standard form. It's not bad. What you do is you start off just like with an ellipse. We start off graphing the center, and then we graph the vertices and co-vertices. The center is going to be at -6, 2. That's right here. Then we've got, in the x direction, because 9 is 3 squared, in the x direction, we're going to move 3. We're going to move 3 to the right and 3 to the left. 16 is 4 squared, so in the y direction, we're going to move 4 up and 4 down. If this were an ellipse, I'd be pretty much done. I would just connect them all, but it's not an ellipse. That minus sign means that it's not an ellipse. It means it's a hyperbola. From here, what I'm going to do is I'm going to use these dots when I connect them and form a box. If I connect these dots, this box is going to help me know where my asymptotes are. My asymptotes are going to be connecting the diagonals of the box. My hyperbola is going to rest inside those asymptotes. It's either going to rest here and here, except going through the vertices, or it's going to rest here and here. The way I decide is I look at the thing that's first. X is first. It's x squared minus y squared. Because x is the positive one, my hyperbola is going to go in the left and right direction. Axis goes left and right, so my hyperbola is going to open to the left and to the right. Opening to the right is going to look like this. Touches the vertex. Opening to the left is going to look like this. Touches the vertex. And that's pretty much my hyperbola. I need focuses. I need foci. To find the foci, first I find the focal length. To find the focal length, I do the Pythagorean theorem. It's not really the Pythagorean theorem, it just happens to have the same variables in the same order, in the same way, but a squared plus b squared equals c squared. I don't have any right triangles here, but it's still the equation I use. A squared is what the first number you see in the denominator, b squared is the second one. A is 3, b is 4. A squared is 9, b squared is 16, so c squared is 25, which means that my focal length is 5. That means that to find my focus, I need to start at the center and go left and right 5. Because my hyperbola opens left and right, I go left and right. If my hyperbola opened up and down, I would go up and down to find my focuses. To the right 5 puts me here. The left 5 puts me here. I'm going to label a few other things on this, but this is the graph now of the hyperbola. So once I graph the hyperbola, you've done it. The things I'm going to label are, first I'm just going to throw some coordinates down here. We start off the center, which was -6, 2. To find the vertices, we went to the right 3 and to the left 3. Added and subtracted 3 to our x. To find the co-vertices, we went up 4 and down 4, added and subtracted 4 to our y. Our foci we found by going left and right by our focal length, which was 5. Starting at our focus and going to the left 5 means I subtract 5 from negative 6. Makes me negative 11, comma 2. This one I'm going to add my focal length to the x, negative 1, comma 2. It all looks a little bit jumbled because I have limited amount of space and I don't want to try moving this around too much because who knows how good I am at doing this. The answer is not very good. The dark blue ones are the vertices, by the way. I used the word, but I'll write it too. The light blue ones are the covertices. I've seen sometimes they're called the covertices, sometimes they're not. The vertices, it's clear to see what they have to do with the graph. They're the tips of the pieces of the hyperbola. The covertices don't really have anything to do with it, graphically, other than they help us figure out the asymptotes. The asymptote is this thing that I know the slope of because I know that I go rise 4, run 3. So in that sense, the covertex does help me figure out the asymptote. I'll make another video all about how to find the asymptote. I do have other names to throw down for you, just because I'm trying to really overwhelm you. This is the transverse axis. And the other one, the one going in this direction, that is the conjugate axis. Whew, that's overwhelming. That's a page full. I mean, that's a mess. It's a mess, but it's a beautiful mess. That belongs in the Museum of Modern Art. I will end the video now because I have to go figure out the rules, figure out how to submit things to the Museum of Modern Art.